This is day 4 of Advent of Cyber 2024, and this challenge is called I'm All Atomic Inside. Sockmas is approaching, and the town of Wareville started preparations for the grand event. Glitch, a quiet, talented security Sockmas engineer, had a hunch that these year's celebrations would be different. With looming threats, he decided to revamp the town's security defenses. Glitch began to fortify the town's security defenses quietly and meticulously. He started by implementing a protective firewall, patching vulnerabilities, and accessing endpoints to patch for security vulnerabilities. As he worked tirelessly, he left breadcrumbs, small traces of his activity. Unaware of Glitch's good intentions, the SOC team spotted anomalies. Logs showing admin access, escalation of privileges, patched systems behaving differently, and security tools triggering alerts. The SOC team misinterpreted the system modification as a sign of an insider threat or rogue actor, and decided to launch an investigation using the Atomic Red Team framework. So the learning objectives today are to learn how to identify malicious techniques using the MITRE ATT&CK framework, learn about how to use the Atomic Red Team tests to conduct attack simulations, and understand how to create alerting and detection rules from the attack tests. So for this challenge, we just need to start with Machine, don't need attack box, and there is a split screen available just like that. So we'll wait until this is fully loaded up. Okay, so it's finished loading, so let's continue reading through. If you don't want to use a virtual machine like this, you can connect to the VPN and then RDP in with the credentials that are listed here. But as we got the VM, we don't need to do that. Detection gaps. While it might be the utopian dream of every blue teamer, we will rarely be able to detect every attack or step in an attack kill chain. This is a reality that all blue teamers face. There are gaps in their detection, but worry not, these gaps do not have to be the size of black holes. There are things we can do to help make these gaps smaller. Detection gaps are usually for one or two main reasons. Security is a cat and mouse game. As we detect more, threat actors and red teams will find new sneaky ways to thwart our detection. We then need to study these novel techniques and update our signature and alert rules to detect these new techniques. The line between anomalous and expected behavior is often very fine and sometimes even has significant overlap. For example, let's say we are a company based in the US. We expect to see almost all of our logins come from IPs in the US. One day we get a login event from an IP in the EU, which would be an anomaly. However, it could also be our CEO traveling for business. This is an example where normal and malicious behavior intertwine, making it hard to create accurate detection rules that would not have too much noise. Blue teams constantly refine and improve their detection rules to close the gaps. Blue teams constantly refine and improve their detection rules to close the gaps they experience due to the two reasons mentioned above. Let's have a look at how this can be done. Cyber attacks and the kill chain. Before diving into creating new detection rules, we first have to discuss some key topics. The first topic to discuss is the cyber kill chain. All cyber attacks follow a fairly standard process, which is explained quite well by the unified cyber kill chain. So you have initial reconnaissance, initial compromise, then established foothold, then you have the iterative process of trying to escalate privileges, internal reconnaissance, move laterally, maintain presence, and then escalate privileges again, until your mission is complete. As a blue teamer, it will be our dream to prevail all attacks at the start of the kill chain. So even just when threat actors start their reconnaissance, we already stop them dead in their tracks. But, as discussed before, this is not possible. The goal then shifts slightly. If we are unable to fully detect and prevent a threat actor at any one phase in the kill chain, the goal becomes to perform detection across the entire kill chain in such a way that even if there are detection gaps in a single phase, the gap is covered in a later phase. The goal is therefore to ensure that we can detect the threat actors before the very last phase of goal execution. A popular framework for understanding the different techniques and tactics that threat actors perform through the kill chain is the MITRE ATT&CK framework. The framework is a collection of tactics, techniques, and procedures that have been seen to be implemented by real threat actors. The framework provides a navigator tool where these TDPs can be investigated. However, the framework primarily discusses these TDPs in a theoretical manner. Even if we know we have a gap for a specific TDP, we don't really know how to test the gap or close it down. This is where the atomics come in. Atomic Red. The Atomic Red Team library is a collection of red team test cases that are mapped on the MITRE ATT&CK framework. The library consists of simple test cases that can be executed by any blue team to test for detection gaps and help close them down. The The library also supports automation, where the techniques can be automatically executed. However, it is also possible to execute them manually. Dropping the atomic. McSkitty has a vague idea of what happened to the compromised machine. It seems someone tried to use the Atomic Red team to emulate an attack on one of our systems without protection. The perpetrator also did not clean up the test artifacts. Let's have a look at what happened. So, running an atomic. McSkitty suspects that the supposed attacker used the might attack technique T1566.001 spear phishing with an attachment. Let's create the attack emulation performed by the supposed attacker and look for the artifacts created. So open up PowerShell prompt as administrator, which we can do here. Right click it, run as administrator, and follow along with us. Let's start by having a quick peek at the help page. Enter the command get help invoke atomic test. So get-help invoke-atomic test. We see this output below, which is telling us how to actually use it, including all the flags, what values the flags take, and how to run it. So the help above only shows what parameters are available without any explanation. Even though most parameter names are self-explanatory, let us have a quick overview of the parameters we will be using in this walkthrough. So atomic technique defines the technique you want to emulate. So for example, the might attack technique T1566.001 could be passed to atomic technique. Show details shows the details of each test included in the atomic. Show details brief shows the title of each test included in the atomic. Check prereqs provides a check if all necessary components are present for testing. Test names sets the test you want to execute using the complete atomic test name. So test names here are download macro enabled phishing attachment. Test GUIDs sets the test you want to execute using the unique test identifier. So GUID is passed to test GUIDs. Test numbers sets the test you want to execute using the test number. The scope is limited to the atomic technique, so this one's saying only do tests 2 and 3, and cleanup. Run the cleanup commands that were configured to revert your machine to state to normal. So our first command, we can build our first command now that we know which parameters are available. We would like to know more about what exactly happens when we test the technique T1566.001. So to get this information, we must include the name of the technique when we want information about, and then add the flag show details to our command. So let's have a look at the command when it's constructed. So we can do invoke-atomic test T1566.001 show details. So there's quite a bit of information here. So technique, spear phishing attachment, atomic test name, download macro enabled phishing attachment. So download macro enabled phishing attachment is the first test. Second test is Word spawned a command shell and used an IP address in the command line. So the output above is clearly split up into multiple parts, each matching a test. Let's examine what type of information is provided in a test. We'll use the test we want to run as an example. So technique was the technique that we're doing. Atomic test, the name of the test. The number assigned to the test. GUID for the test. The description. So this atomic test downloads a macro-enabled document from the Atomic Red Team GitHub repository, simulating an end user clicking a phishing link to download the file. The file phishing attachment.xlsm downloaded to the temp directory. So attack commands uses PowerShell without elevated privileges. The command it ran URL is equal to the phishing attachment invoke web request and send it to the out file of temp directory of temp.xlms. So cleanup command remove item env temp xlsm. Any error actions ignore, and there were no dependencies for that one. So phishing spear phishing attachment emulated. So let's continue and run the first test. Before running the emulation, we should ensure that all required resources are in place to conduct it successfully. To verify, we can add the flag check prereq to our command. So if we do invoke-atomic test T1566.001 test numbers 1 check prereq, our prereqs are met. So now that we have verified the dependencies, let's continue with the emulation. Execute the following command to start the emulation. So invoke-atomic test T1566.001 test numbers 1. So we enter that path to Atomic's folder, executing test, and it's done executing test. Based on the output, we can determine that the test was successfully executed. We can now analyze the logs in the Windows Event Viewer to find indicators of attack compromise. So detecting the atomic. Now that we have executed the T1566.001 atomic, we can look for log entries that point us to this emulated attack. For this purpose, we'll use the Windows Event logs. This machine comes with Sysmon installed. System Monitor provides us with the detailed information about process creation, network connections, and changes to file creation. To make it easier for us to pick up the events created for this emulation, we will first start with cleaning up files from the previous test by running the command scene1-cleanup. Now, we will clear the sysmon event log. So open up Event Viewer by clicking the icon on the taskbar right here, or you can also search for it in the Start menu. So with this open, we now need to go to Application Services, then we need to go Microsoft, Windows, scroll down until we find sysmon right here, and then select Operational. Actually, what we need to do is right click Operational, and then do Clear Log, and click Clear. So with that clear, now we can run the test again. So now we'll be creating the logs, and inside Event Viewer, if we refresh, it should have only the logs that we created. So with this one selected, we can see the command line PowerShell is running URL localhost phishing attachment.xlsm, and it's creating the URL for the phishing attachment. And if we keep going through these logs, there might be other stuff. No, it looks like that was the only one that we had to look at. None of these other ones seem to be relevant, so just this one here, you can see it's running that PowerShell command. So click on each event to see the details. When you select an event, you should see a detailed overview of all the data collected for that event. Click on the Details tab to show all the event in a readable format. Let's take a look at the details of these events below. The data highlighted is valuable for incident response and creating alerting rules. So navigate to the directory, Users Administrator. So we'll start at this PC and let's go C drive, Users, Administrator, App Data, Local, and Temp. And we can see all the files in here, and we can open phishingattachment.txt. And as we can see, we've got the flag right here. So we'll just minimize that for now, and we'll come back to that later. Now that we know which artifacts were created during this spear phishing emulation, we can use them to create custom alerting rules. So in the next section, we will explore this topic further. Alerting on the atomic. In the previous paragraph, we found multiple indicators of compromise through the sysmon event log. We can use this information to create detection rules to include in our EDR, SIEM, IDS, etc. These tools offer functionalities that allow us to import custom detection rules. There are several detection rule formats, including Yara, Sigma, Snort, and more. Let's look at how we can implement the artifacts related to T1566.001 to create a custom Sigma rule. So two events contained possible indicators of compromise. Let's focus on the event that contained the invoke web request. So that was the full command, PowerShell running URL with the Excel file, invoking web request, URI, and then URL out file this. So we can use multiple parts of this artifact to include in our Sigma rule. So there's invoke web request, there's URL with the phishing attachment, and there's the phishing attachment itself. So combining all these pieces of information in a Sigma rule would look like this. So you give it a title, an ID, a description of what it does. So it detects the usage of invoke web request to download phishingattachment.xlsm and the creation of the file phishingattachment.xlsm. So the log source is sysmon Windows process recreation, and to detect it, selection invoke web request has an event ID of 1, and the command line contains invoke web request and the Excel file. And then selection file creation, event ID 11, and ends with the Excel file name. And for this rule to trigger, either one can run. So the one may not run, but the other can. So false positives, legitimate administration activity may use invoke web request, and legitimate Excel files may be created with similar names. So they've also added tags for the MITRE attack, and they've added tags for how this event can map to MITRE attack. So web service, application layer protocol, PowerShell, ingress tool, transfer, and spear phishing attachment. The detection part is where the effective detection is happening. We can see clearly the artifacts that we discovered during the emulation test. We can then import this rule into the main tools we use for alerts, such as the EDR, SIEM, XDR, and many more. Now that Glitch has shown us his intentions, let's continue with his work and run an emulation for ransomware. As Glitch continues to prepare for SOCMUS and fortifies Wareville's security, he decides to conduct an attack simulation that would mimic a ransomware attack across the environment. He is unsure of the correct detection metrics to implement for this test and asks you for help. Your task is to identify the correct atomic test to run that will take advantage of a command and scripting interpreter. Conduct the test and extract valuable artifacts that can be used to craft a detection rule. Okay, so now it's on to the questions. So first thing, What was the flag found in the file? So if we open that again, THM glitch testing for spearfishing. Okay, so what attack technique ID would be our point of interest? So I think it was talking about this one, but let's just look at the hint quickly. Okay, yep, so we're now looking at this new one. So let's copy this, and we can do MIDO attack and paste in that. So T1059, T1059. So what MIDO attack sub-technique focuses on window command shell. So we can go into MIDO attack, and we should see Windows. Let's try Windows command shell, which is right here as a subtask, and the ID is 003. So T1059.003. What is the name of the atomic test to be simulated? So if we go back to here, we can. So which one do we want to do? Okay, we'll do show details, and we change this command so it's T1059. And we change this to 03. Let's do show details. Okay, that seems to be quite a bit of a test right here. So what is the name of the atomic test to be simulated? So I assume we'll be doing the first one again. Does that fit in? Create and execute batch scripts. That doesn't fit. Well, the next one. That doesn't fit. That one doesn't fit either. Okay, it looks like this one. Simulate Blackbyte ransomware print bombing. So simulate Blackbyte ransomware print bombing, and that's correct. What is the name of the file used in the test? So in this test, or if we can, Wareville ransomware.txt, I assume is the one. Wareville ransomware.txt. That is correct. So we will now run it. So we'll change it again. So it's 159 sub 3 and test number 4, I think. Yeah, that seems to be correct. So let's run that. So WordPad, it's ran it, and let's save this. So we'll do T1059 underscore 033 003. So what is the flag found from this atomic test? So assume that PDF is what it was. So we saved that, and now let's open it up. And we can see here, Glitch is working on testing the security posture before SOCNAS is here. I will run as many tests and ensure we are all safe and uncover all threats before they hit us. And we've got the flag right here as well. So let's copy that and paste it into here. And that is all the challenges completed. Sorry, that is day 4 of Advent of Cyber 2024 completed. If you like this video, make sure to like and subscribe.